Hey guys, I just wanted to make a quick video over the worksheet that was handed out today. I wanted to show you how I completed the worksheet, so maybe I'll help you a little bit. So this is the first thing I do. I make sure I have in front of myself the trig identities we learned earlier in the week. Like here's the reciprocal identities, and then here is the quotient, and I think they call it ratio identities as well. So here's the quotient ones or ratio, and then reciprocal. Then here's the Pythagorean identity. So you need to know this as your foundation. So what I do is I have this in front of me. Then what I do is look at variations of this identity. How else could I write this? Well, I could also say this is sine squared theta equals 1 minus cosine squared theta. There's another identity. Or you could say cosine squared theta equals 1 minus sine squared theta. So we just created two more identities. So these three you can use in a second. We'll do the problems. Then here, if you go back to your notes, you recall that we divided them all by sine. Go back to your notes in a prior video. If you divide this by sine, you would get 1. Divide this by sine, you would get cotangent square theta. And if you divide this by sine, 1 over sine is cosecant square theta. There's another identity. Then if you go back in the notes, what if we divide this by cosine? Sine over cosine is what? Tangent square theta? Plus cosine over cosine is 1. 1 over cosine up here is secant squared theta. So here are some more. Now, if we wanted to, we could go one step further and say, what does cotangent squared equal? Well, we could say cotangent squared equals what? Cosecant squared theta minus 1. I mean, that might pop up. I don't know. Here we could say tangent squared theta equals secant squared theta minus 1. So once you have a Pythagorean identity, you can do any variation off of it, like add and subtract, in order to create a new one. So these are all identities that might be fair game on the worksheet today. So what I would do is have this in front of you as you work out the assignment today. So I thought I would do a few of them. So the cool thing about this homework today is that you know the end result has to get to a single term, either a single trig function or a single number, like a constant. So that's kind of cool. So we know what our goal is to simplify. Another cool thing is at the bottom of the page are the answers. So at least you know the answers and if you've got it right. So I thought about working out a few of them. So what if we do like 7? Okay, 7, I notice 1 over sine square A minus 1 over tangent square. Well, I know 1 over tangent over here. 1 over tangent is the same thing as cotangent. So this is what I'm doing. Cotangent squared, right? So that's the same thing. I'm just substituting. Then I know, 1 over sine squared A. Oh, this is A. Okay, cotangent squared is what? Cosine over sine. So I'm going to substitute again. So cosine theta, or A, I guess, sorry, over sine squared A. Okay. So then I go, these are two fractions. So now it's back to your algebra skills. Fractions with the same denominator, you just put them together. So it's 1 minus cosine squared A all over sine squared A. Then I go 1 minus cosine squared A. Go back up here. Well, that's the same thing as sine squared A. So it's a lot of substitution, like a lot. So I substituted, 1, 2, 3 times, and then something over itself is 1, and the answer is 1. Okay, so this is how you would do these. So let me raise it up a little bit. So first thing I did from the problem is I replaced 1 over tan with cotangent. Then I saw this was a sine. So I was like, okay, what is something over here that could have a sine in it? Oh, cosine over sine is cotangent. Then I saw, they are common denominators. So let's put them together. Then I saw again, I can substitute this because that came from up here. So as you'll see, it's a lot of substitution. All right, let's try another one. What about, we can do 9 if you like. Okay, so 9, 1 over cosine squared. theta minus, well, 1 over cotangent squared. So 1 over cotangent squared is tangent squared theta. So I'm just so there's my first substitution. Then I was like, okay, 1 over cosine squared theta minus, well, tangent is sine over cosine. Oh, well, put this together. 1 minus sine squared theta all over cosine squared theta. Well, 1 minus sine squared theta is over here. Where's it at? Right there. It says cosine squared. So substitution again. Oh, this one's also 1. Okay, let me try to pick a different one. All right, so hopefully that helps. Okay, let's do one more. All right, let's do, I don't know which one would you like me to do. I don't know, 12. 12 looks really interesting. 12 and 14. Okay, let's do 12. Okay, 12 is 1 minus cosine x times 1 plus secant x, and then times cosine x. Okay, so here is a binomial. So you did the distributive property here, FOIL. So 1 times 1 is 1, and then plus secant x minus cosine x minus cosine times cosine x times secant x. All of this times cosine x. Okay, so let's see what we got. I have 1 plus secant x minus cosine x minus, well, what is secant? Secant, if you go back to your other page, is 1 over cosine. So there's my first substitution. So all of this times cosine x, right? Okay, then this crosses out, right? So if this crosses out, right, you're left with 1 minus 1. Well, that goes away. Then you have secant x minus cosine x. You have this left over times cosine x, okay? So now what do we have? Well, then now we'll multiply this into here. So we'll have secant, which is secant again? Secant is what? 1 over cosine x, and then minus cosine squared x. That looks a little more complicated. So I think I'm going to put this back. Let's do that. Let's see. Actually, I messed up. So 1 over cosine x. Okay. 1 over, my bad. 1 over cosine x is this times, there we go, cosine x. That's because I'm doing the distributive property. Minus cosine x. There we go. Now, this crosses out, so we're left with 1 minus cosine squared x. So I'm going to go back to the previous page. 1 minus cosine is sine squared. So sine squared x is my answer. Okay, so hopefully those 3 examples, I hope you do a little bit better. If not, email me and I can make another video and upload it later tonight to help you. Otherwise, there's 3 examples for you. Hope it helps. If not, email and I will do some more. Okay, thanks.